Welcome to Mastering Electron Beam Machining, Precision Cutting Unleashed. Visit us at www.agstech.net. In this video, we will explore the fascinating world of electron beam machining, or EBM, with some artistic effects and animations. ABM is a cutting-edge technology that uses a focused beam of electrons to machine materials with incredible precision. Here, you can see the artistic version of an EBM machine and its key components, including the electron beam gun and the vacuum chamber. Compared to other machining techniques, EBM offers unique advantages such as minimal thermal distortion and the ability to machine hard-to-cut materials. Let's take an artistic closer look at the electron beam gun. This component is crucial for generating and focusing the electron beam. The vacuum chamber is essential for maintaining the environment needed for the electron beam to function effectively. Here, the workpiece is mounted and ready for machining. ABM is widely used in industrial settings for its precision and efficiency. This split screen shows the machine in action, drilling holes with remarkable accuracy. The power density of the electron beam is high enough to cause rapid material evaporation, allowing for precise cutting and drilling. ABM can be performed using single or multiple pulses, each offering different benefits depending on the application. Here we see a complete artistic overview of the EBM machine and its components, highlighting its complexity and precision. The process parameters of EBM can be finely tuned to achieve the desired machining results. This infographic illustrates the key parameters. ABM is suitable for a wide range of materials, including those that are difficult to machine using traditional methods. The unique capabilities of EBM allow for the creation of intricate hole structures that are not possible with other techniques. One of the key advantages of EBM is the minimal heat affected zone as compared to traditional machining methods. EBM is also capable of working on fragile materials without causing damage, making it ideal for delicate applications. Non-conducting materials must, however, undergo certain processes prior to being processed by EBM. High aspect ratio hole drilling is another area where EBM excels, providing precision and depth control. The advantages of EBM include high precision, minimal thermal distortion, and the ability to machine hard materials. This infographic highlights these benefits. However, EBM also has some disadvantages, such as the need for a vacuum environment and high initial costs. This infographic outlines these drawbacks. ABM is revolutionizing various industries, from aerospace to medical implants, by providing precision at the speed of electrons. Visit us at www.agstech.net. Thank you for watching Mastering Electron Beam Machining, Precision Cutting Unleashed.